Hello, everyone. Thank you for joining us for today's Coringo Tech Tuesday webinar. This session's topic is providing NFS access to object storage using SwarmNFS. I'm John Bell, Senior Consultant at Coringo. Today I have as our guest Michael Q. Brame. Q and I will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have some resources available for you via the attachments and links window on your view screen. If you have any questions after the webinar, you can always reach us by email at info@coringo.com. So just some quick introductions. Again, I'm John Bell. I've been with Coringo for almost 9 years, and I'm a senior consultant on the design, implementation, and management of object storage. I work with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions. Q, please go ahead and introduce yourself.
Thanks, John. I'm Michael Brame. Everybody around here calls me Q. I've been with Coringo since 2006, and I lead the quality engineering team. Over the years, I've had a hand in testing every one of our products, as well as helping with on and offline support.
Excellent. Thank you, Q. And as Q states, the Q is for QA, and he's been with us from almost the very beginning. So if Q doesn't know it, there's probably very few people that do.
Yeah, that came around because at the time we had 5 mics in the company.
That's right. I remember that.
Yeah.
Very good. Okay, so briefly before we dive into things, a quick history about Coringo. Coringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Coringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Coringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Labs, UK Science and Technology Facilities Council Scientific Computing Department, Texas Tech University, US Department of Defense, the Brazilian Federal Court System, British Telecom, and hundreds more worldwide. So just a quick agenda before I hand things off to Q for the presentation. We did go through a brief history. We're going to go through a brief history of NFS and object storage. We'll walk through some specific SwarmNFS features of note, and we'll also provide a deployment checklist, the things that you'll need and have in place in order to deploy SwarmNFS and start using it. We'll also go through some quick notes on the new patch API call that's used to help improve the performance of SwarmNFS when interacting with our object storage solution. Q-Mike is also going to go into a demo, and then finally we'll wrap up with any remaining questions and answers that might be outstanding. So with that said, Q, I'm going to go ahead and hand it over to you.
Thanks, John. All right, so we'll go through a brief history of NFS and object storage. What you'll typically find with the NFS gateways over object storage is a heavy top-down approach. You start with your NFS server on top of a fuse connector, and that's sitting on top of a spooler or cache, which then goes through a proxy to your storage cluster, and all that operates its own isolated namespace. And as we know, because as a company, we've built this setup 3 different times, that it becomes a complex system that's hard to scale and makes HA really difficult. So we decided to take a different approach with SwarmNFS. SwarmNFS is not a gateway. It's a lightweight protocol converter. And as a protocol converter, all it does is converts NFS to SCSP that Swarm understands. It runs as a single Linux process, and that process can be run on bare metal or in a VM. As this graphic indicates, there's no local caching or spooling involved. Once the client receives the write response from the file, it's in the object store and it is protected. So at no point is the object in a transient state where it's not in the cluster. As a native integration with Swarm Storage, SwarmNFS can leverage features like parallel data streaming and upload by patch for performance. And we'll speak about patch in just a little bit. But currently, SwarmNFS works with a unified namespace that's utilized by all our other Swarm products, which means any objects written to the cluster via NFS, S3, or HTTP are visible to all of our products and applications in that ecosystem.
Just to jump in real quick, it looks like we have a question about that third bullet already. The question is, how long until after a write is performed until the file is fully protected when it's written through SwarmNFS? How quickly can you guarantee that the object is in place and is fully protected?
Excellent. Yes. Well, since we don't spool it, as soon as the client gets the right response, it is in the cluster. There's no place where the object will sit. So once you get the right return to the client, it is in the cluster and fully protected.
So that'd be the equivalent of, say, a 200 or a 201 HTTP return code from the storage backend. Is that right?
Exactly. As soon as you see that, it is in the cluster.
And I believe since we ship the object storage by default to do replication on write, not only does it guarantee that the write succeeded, but it guarantees that its backup is in there as well. And in similar fashion, we're guaranteeing that for erasure coding, the erasure coding set and its associated manifests have already been committed as well. Is that right?
That is absolutely correct. So the manifest is in there, and it's completely replicated due to replicate on write being on by default. And if it's a large enough object, it'll be EC encoded, and everything is set. There's no additional post-processing to protect it. It has already been done when you get a right response.
Yeah, and that's the big advantage to this new architecture for our NFS protocol implementation. Like you called out in the previous slide, it's almost like the fourth is a charm. we 3 different times we tried to do this with spooling and caching, and every time we tried it that way, it introduced more problems than it was trying to solve. And doing it in this stateless fashion and counting on the backend storage solution to guarantee that the commit has taken place is a much better approach. Simpler, cheaper, faster.
And that's the big thing. You mentioned it being stateless. Because of that, we can scale it out by spinning up more of these as VMs or bare hardware. We can spin up more SwarmNFS servers, and since it's stateless, it doesn't matter which one you hit for your write or read, it'll just work since they're all using the exact same namespace.
Right, per your last bullet. And that's the advantage to the unified namespace.
Correct.
Very good. Thank you, Q.
Sure thing. Now, we did mention that it was lightweight, so for our deployment checklist, we'll see that SwarmNFS isn't very physically demanding. We need only about 4 gig of RAM and 2 CPU cores as a minimum. These requirements do increase with the number of exports and the client load, but as we stated, the SwarmNFS can be run on bare metal or VM, so as your requirements go up, you can just either throw additional resources at it or spin up more of them for scaling.
Okay, if you deploy multiple SwarmNFS installations, Q, is each one of them capable of presenting the same export list to a set of clients?
Absolutely. Since they all get their export list from configuration file, if you use the same configuration file for every SwarmNFS server that you spin up, it will pull the exact same listings and have the exact same permissions and users and everything that comes with it.
Well, that's great, because that means if I have an extremely large NFS client population, I don't have to worry about getting them to be able to work through just a single SwarmNFS installation. I can parallelize that out, and I know that they'll all see the same exports.
That's absolutely correct. And along with the hardware requirements, we do also say that obviously you're going to want Swarm Storage Cluster in there, and Swarm Search for the unified namespace, and Swarm Gateway to go through. And the reason we want Swarm Gateway in there is for security reasons. Previously, we would spin up our own security and our off and off algorithms. What we'll do in this case, since it is a Linux process, is use Linux for security. So if you tie your SwarmNFS server and your client into an LDAP, you can use those LDAP users through your gateway to access your content, and every user has their own content, and you can share as you would in your normal corporate infrastructure.
And as I recall, we integrate also natively with Active Directory, and basically we effectively support anything that will work with Linux PAM. Is that right?
That is absolutely correct. Yeah, and that's one of the reasons. Well, one of the benefits of having it as a Linux process that we let Linux handle all that. So if Linux can access it, we can access it.
Right. So if you're Kerberized or whatever, it all just works.
Yep. We didn't rewrite that. We didn't redo it. It's already been done for us. Moving forward. So we talked about Swarm Patch briefly. SwarmNFS utilizes Kringo's patented patch feature that was introduced in Swarm 9.5. It was previously patent pending. We recently were awarded that patent. And what it does, only object changes are transmitted to storage, and unchanged data is not resent. It is effectively a put. And so existing data and new data are passed together by Swarm on the back end, so the client doesn't need to be aware of what is new and what isn't. Swarm takes care of all that. And the end result of using Patch for SwarmNFS is greater concurrent write performance.
So if an NFS client has one of these SwarmNFS exports mounted, and let's say it's a text file, and you make a change, it's not a process of where it pulls out the entire object, and then you turn around and write an entire object again to implement the change. It's actually patching the data within the object. Is that right?
Yep, correct. Yeah, the updated bits are the only ones that get sent. The rest do not, because there's no need to.
Mm-hmm. We've got a question here, Q, and it's a good one. What happens when two of your SwarmNFS deployments perform a write or update against the same object?
The last one wins.
Okay. And that's the same for if two NFS clients were to do the same thing. Is that right?
Absolutely. It works the exact same way.
Okay. So the last write wins is the answer to that question. That's a good question. Very good.
All right. So moving on to use cases.
Oh, I had another question for Patch. I'm sorry, Q. I'm kind of lagging on you here. Bear with me. This is a great feature for SwarmNFS. Can you use Patch with other client implementations other than SwarmNFS? Can that call be made?
Yeah, absolutely. It is not specific to SwarmNFS. It is actually in Swarm itself. And so we implemented a new verb, the patch verb. So anybody who can speak that, get the syntax correctly, anybody else can use it.
So it's part of the RESTful API that we provide with Simple Content Storage Protocol.
That is absolutely correct.
Excellent. Very good. Thank you.
Sure thing. And yeah, any Swarm storage after 9.5, we'll have we'll have Patch in there. So yeah, you can absolutely use it for anything, for products other than SwarmNFS. Now moving on to use cases. Now we'll have a demo in a bit, and you'll see this. And even though it looks like a file system, SwarmNFS is not a file system replacement. It's mainly an ingest tool to integrate existing NFS applications and allow backend storage to use robust object stores. It's essentially an API endpoint to allow third-party software that writes or reads NFS to work with object storage without any internal changes to that third-party software. It's ideal for backups and archiving workloads and things like VM snapshots. And as we wrote about in our recent blog, it works great for capturing video streams. It is not intended for workloads like live file editing or databases that are transactional. So it looks deceptively like a file system replacement, but it is not.
Right. Yeah, we've made great strides with the patch verb, and it certainly helps get us closer to being able to achieve that goal of looking, quote unquote, just like an NFS server. But Q is absolutely correct. It is not a full bore replacement for a traditional NFS filer.
Yes, that's correct. We've actually had support calls come in where we'll have customers say, "Hey, we're using like Adobe Premiere to edit some videos and things aren't going quite right, or and the edits aren't working as we expect." Like, well, don't do that. It's really really to look at it and say, "Oh, well, yeah, this is a file system."
And for mount to a protocol translator, it's actually quite encouraging to see people attempt to do such operations with it, and they get quite far with SwarmNFS. When they're attempting to do these low-level block changes that would traditionally be done or emulated through a traditional filer, and we get closer to this all the time. And as SwarmNFS development proceeds, I'm certain we'll eventually be able to tackle workloads like that. But for now, it's not a good replacement for those type of use cases.
Indeed. So the current release features, we're currently on SwarmNFS 2.4. And SwarmNFS 2.4, which was released a couple months ago, we introduced support for Elasticsearch 6 and support for Swarm 11. We are currently working on SwarmNFS 3.0. And SwarmNFS 3.0 will streamline internal operation using the new gateway listing service. And we have improvements to logging there. And we've introduced improvements for read performance for very large files. And those tend to be files that are 10 gig or larger, and our read performance is greatly increased with those.
Yeah, we've made great strides with the video file manipulation use case, and that's where that large file read performance really comes into play.
Exactly.
I do have one quick question here for you, Q, before we bounce to the next slide. And the question is, can I install Windows for NFS and mount it as a map drive?
Unfortunately, not at this time. Currently, the only NFS clients we support are Linux-based. It doesn't work quite right with OS X or with Windows at this point.
What are the limitations, Q? What's the hurdle there?
Since we support NFS 4 and NFS 4.1, it has to adhere strictly to those, and the Windows NFS clients at this point don't quite.
Oh, so it's a NFS version adherence. It's a spec issue with NFS.
Exactly, it's a spec issue with NFS. That's correct.
Yeah. And what was the versions that caused problems?
Well, we're currently using either NFS 4 and NFS 4.1, and so we have yet to see a native Windows NFS client that'll stick to that.
Right, that's what it is. Okay.
Yeah.
Perfect. Thank you.
Sure thing. And unless there are any questions, we'll go ahead and go into a demo.
Nope, you're all clear. Go ahead, Q.
All right. Go ahead and share my screen.
Actually, while you're sharing your screen, another question that came in is, will there be a SMB equivalent available anytime soon?
It's not currently on the roadmap. If we get enough calls for it, it's something we can certainly do, but not at this point.
Okay, thanks.
All right. So one thing we'll do first is go through the configuration for a SwarmNFS share, and that's done through our Swarm UI. So we said that some of the requirements are to have a Swarm cluster up and running, which I do, and a Swarm search feed, which I currently have here. This is my Swarm search feed. And so on Swarm UI, go through Settings and NFS. And you can add your exports here. And this is the one we're going to use for this demo. I have an export called SwarmNFS 2. And so all we need to put in here is your storage IP address. In this case, I'm using the IP, or the address of my gateway server. And my host is my Elasticsearch host. My search index is my feed that I defined in the previous tab. Export path is an arbitrary name, and this can be anything. So when your NFS clients mount something, this export path will be what they mount. For your scope, you're going to pick your domain and your bucket. In this case, the domain I'm going to use is nfstest1.test domain and bucket nfstest2, which I can show you my content portal is here. This is my domain, nfstest1 domain, and the bucket, which I have pre-populated with 3 Hello World files. Go down to cloud security. For cloud security, you can use various methods. For this demo, I'll use single user, which means that this single user, when you log into your NFS share, any files created or any reads that you're doing will be using this user. In this case, it's an admin. If you want to use a Linux-specific LDAP users, you'll go and you'll use a session token instead. And when you use session token, SwarmNFS will create a token based on the user that's currently trying to access it. And the other settings we don't need to touch, so you go ahead and make the changes there.
There's a best practice in that previous UI section that you were showing. There's kind of a change in approach and best practice that we're going to start promoting for use of SwarmNFS, and I believe that's related to direct access versus going through gateway. Is that correct?
Correct, yes. You can either go direct to Swarm or through the content gateway. For as best practice, we do encourage going through the content gateway. That way you get your policies enabled, your auth and auth, and various mechanisms that will help you access your data through the content gateway that you do not get direct to Swarm. And so if we're going to go best practice, we're definitely going to go through the gateway and get those additional features.
Mm-hmm.
So once you have your export defined, and we have our data, I have two tabs here. These are both VMs. This one is my SwarmNFS server. And you'll see SwarmNFS will come as 2 RPMs to install, your library RPM and your basic RPM. And so once you install those 2 RPMs, just run the SwarmNFS config command, and it will ask you for a URL. That URL will be generated here in the Swarm UI. So when you save your export, it'll generate this UI. So all you do is put this UI, copy link, into here. And that is it. You go ahead and hit enter, and it'll go ahead and generate your config file. Right there. And so this is all automatically done. So when you run SwarmNFS config, it configures your configuration file, and this configuration file tells SwarmNFS where to pull your export with all your user information and your export information, and it starts it on its own. So we'll see. That it is currently running. And that's all I have to do on my server. So install your 2 RPMs, do your config, and then once the service is started, you are ready to go. So this is our client VM, and I'll do disk free to show you we currently do not have any exports mounted. I'm going to do a simple mount command, and my server. And remember, when we configured it, we put this export path as NFS test 2, which I will put here, NFS test 2, and then where to mount it locally. Do a mount, NFS test 2, and then we'll do another disk free, and now we'll see that my export is mounted, and it shows 11 terabytes in size, 6.9 terabytes used, 4.1 terabytes available. So if we go back to our cluster, we will see that my Swarm UI says 6.2 or 62% used. That's because I have 1% trapped. So the size matches and the available matches. Now we'll actually go ahead and CD into that directory, and we'll see the same 3 content that I had here. Now, we can actually read these guys out, and surprisingly enough, they'll say hello world. And go ahead and make a directory, and let's use today's date, 07/28/2020. And let's create right there. Let's CD into it, and let's create another hello world file, because we love hello world files. And then 07/28. Let's call this webinar text.
There we go.
There it is. So let's go ahead and read that out. And we'll go over to our content portal. It's not there because I haven't refreshed. And so we'll see that the directory that we created is actually labeled as an application directory, and it is a 0-byte file. And the webinar file that we just created is right there, and we see all the metadata. And that brings up a feature that SwarmNFS surfaces that you won't normally see. is you can read and write file metadata straight from the command line. So if you read out the file, :metadata, instead of the content, you will actually pull the metadata. And from here, what we can do is I should have a sample. So I have a file that I created beforehand called metadata, and in that file, I created just 3 custom headers. So what I'm going to do is cat that into my webinar metadata. And by reading those headers into the :metadata, it actually adds the metadata headers to my object.
Yeah, and that's the key. It doesn't overwrite the metadata that's there. It appends it to what's already there.
Right. There it is at the very end. And go and pull up through here. And here it is in the content portal, which means it is attached to the object in my cluster, in my ecosystem. I don't know if you can see on the screen the custom metadata that we just wrote. So with this, if you're using your metadata for collections or custom searches or anything, instead of modifying the metadata or tagging videos or anything by hand, you can do it programmatically through scripting or pretty much any way you want to do it. It's available, so we just make it easy that way.
So Q, the data ingest itself doesn't necessarily have to go through SwarmNFS with the supporting unified namespace and the mutual cluster resources. You could potentially say write things into these domains and buckets using S3 or our native API, and then if you were to list it on the SwarmNFS side, you would see that listed in the mount point. Is that right?
That's absolutely correct. Since we're reading from Swarm Search, anything that has access to Swarm Search will populate the exact same objects. So also along those notes, along those lines, anything that we enter here, like say we use rsync to back up, user directories, you can pull those using S3 or SCSP as well. So anything that comes in here can get out anywhere and vice versa. Absolutely.
So it also helps with collaboration on data, where you have, say, RESTful clients that are using S3 or SCSP Plus that are manipulating data in the cluster. And then you may have clients that are only able to access via SwarmNFS, and they would still see that same set of data.
Yep. As long as the users that you've used have access to the data, they can absolutely see it.
Does this support the export of collections?
It does. It does. Well, you can't read the collections through NFS, but the metadata that you modify here can be pulled with collections through the content portal. Absolutely.
Okay. Excellent.
And other than that is about it for the demo. I can remove that directory we just created because it's got to clean up after yourself, kids. And so we'll see that's gone. Search here, and all the new data that we created is now gone.
Yeah. And per that previous question, and as you see, as Q creates and removes data, the verification of the commit is actually quite fast.
Yes. Yeah. Well, once again, going back to the caching and spooling, since none of these commands are cached or spooled, as soon as I get the return back, that's gone to the cluster, and the cluster's taking care of it, and then responded back, hey, it's done. When it says it's done, it is actually done.
And that's why you're able to see the same data, even though you're accessing it with various different protocols and clients. They're all pretty much going to see the same data at the same time.
Yep, absolutely.
Very good. Is that all you had?
Yeah, that was the whole thing. I mean, as we've seen here, and I was just in the slides, it is deceptively easy to see this as a file system replacement and use it, and it'll probably work for you. But that's not the intent. And the intent is just as an ingest tool, as an API endpoint, and it works really well for that.
And it's a great way to integrate clients that you have that were not originally set up to interface with a RESTful endpoint. for example, you did a blog recently here, Q, where you integrated your webcam at home with using SwarmNFS. And for that reason, because the webcam was purely designed to write to an NFS endpoint, but you didn't want to do that. You wanted to put it into Swarm storage instead for the video files that were captured.
Exactly. And one of the things was the issue that I had was if you wanted to continuously record, you know, you had to pay a pretty high fee to the cloud, or you know, you could write it to your local machines, but then I didn't have a whole lot of storage. But I realized I had a whole bunch of storage in my Swarm cluster. And so it was easy to leverage that. Since it already knew how to speak NFS, I just pointed it to my SwarmNFS server, and there were no changes that I had to make in my monitoring software. I mean, it just said, oh, that's an NFS endpoint. I could write to that, and it just went there. There were no changes that I had to make. It was just really nice.
Yeah, and for those in the audience who are currently, you know, working against requirements where you're trying to identify ways to take advantage of, say, hybrid cloud approach or whatnot, and somehow integrate that with NFS protocol, you know, within your organizations. You know, Q's blog, where he goes into how he made this work with the NFS webcam, is an excellent exercise as to how you can make all of that come together. We do have one question, Q, and this is a good one. Let me present this one to you. And the question is, can you use a layer 4 load balancer to cluster SwarmNFS servers?
Yes, absolutely. And that's one of the ways that we use it in our test environment is because since it's stateless, you know, as far as the client is concerned, it doesn't care which one it gets, you know, as long as it talks to somebody who can speak NFS, so we can absolutely use it.
Right. Yeah, and like you say, we've tested it that way in-house, and we know that it works. So you most certainly can.
Yes.
And we have a nice, lively audience today. I've got another question for us. And the question is, what happens if your backend object store is remote? For example, you have to reach it over a WAN connection, you know, for the NFS client. I guess in this case, a better use case would be you have an NFS client in SwarmNFS, and SwarmNFS has to go over a WAN connection to Swarm storage. Does that have a severe impact on the performance?
It depends on the speed of your WAN. SwarmNFS can do it. You just have to increase the timeouts so it doesn't time out too early. But yeah, as long as you increase the timeouts, it'll work. But yeah, as far as how far performance is impacted, it depends on the speed of the WAN.
Right. It's going to be, as it always is in the case of wide area connectivity, a question of both bandwidth and latency. You know, if you're pushing very large files over a very small WAN link that has a large latency associated with that leg, obviously it's going to have an impact on performance because, like we mentioned previously, there's no spooling or caching involved. SwarmNFS is stateless. So
yeah, all it's doing is converting protocol from one protocol to another. And so since it's doing very little, it's as if it's not even there. So you'll have similar performance as if you're going straight from your client to your cluster over WAN.
Right. And there are a lot of ways to address a use case that's painted you into that corner. One approach that I've used in the past, Q, is you would have a local Swarm storage at a satellite office, and you would have SwarmNFS, you know, set up to point to that local Swarm storage, and you'd have all the NFS clients there interacting with that. And then what you would do is you would set up a wide area replication from that satellite office's Swarm cluster to a mothership Swarm cluster that may be at headquarters. And bearing in mind that this is a unified namespace, and what that means is that all the domain, bucket, name context that exists in that satellite office Swarm cluster is going to end up being replicated at the mothership cluster. And if you were to set up gateways that access the appropriate admin domains at the headquarters location, you're going to have access to exactly the same data that was ingested at the satellite office. And that's one of the ways we solve the locality issue with architectures like that. Is it's actually quite easy to turn up a a smaller Swarm storage cluster at these satellite offices, and then just have them replicate up, depending on what type of architecture you want to use, whether it's spoken hub, end-to-end relationships for the replication feeds, whatever. It's a lot easier and faster to do it that way.
Yeah, satellites, they don't have to be big setups.
No, they don't. Yeah. All right, very good. Well, that's an excellent demo, Q. Thank you very much. I appreciate it as always. And we are done for questions for today. So I'm going to go ahead and wrap things up. To keep up with Coringo, please follow us on Twitter, LinkedIn, or Facebook. And again, if you do have any additional questions or would like to schedule a custom demo, please email us at info@coringo.com. And again, thank you everybody for joining us today. And I'd like to take this time to also invite you to join us on August 25th for our next Tech Tuesday webinar. And we're going to have Ryan Meek and Jose Gonzalez presenting how to incorporate cloud into your DR strategy for us on that day. So we look forward to seeing you there. That said, thank you again, everyone. We hope you all have a great day, and we'll go ahead and shut things down. Take care.
Everybody.
Bye-bye.
Hey.